I created an app. So the core idea behind this app is that it will help you figure out what target you should image on a given date, at a given location, with a given telescope and camera. This is the homepage of the app, what you're greeted with. It gives you 3 targets that are the top 3 best targets to image tonight. And then down below gives you top 5 nebulae, top 5 galaxies, and top 5 star clusters. Up top you have options to pick the date. You can change your location and also the imaging preset that you're going to use, which is the camera and telescope. This report takes into account the current moon conditions. At the top it says moon is 100% illuminated tonight, and because of that it's going to exclude any broadband targets, which is why there's no galaxies, because galaxies are broadband targets. So that means that you're left with narrowband nebulae as well as star clusters. I can change the telescope and camera I'm going to use. This is a more wide field scope, so now my options have changed to more wide field targets. I can click on one of the targets to bring up a detailed page about this target, get an image, and all these images were pulled from NASA's astronomy pictures of the day. Gives you the name of it, what kind of target it is, constellation, coordinates, magnitude, size, and then 2 scores here. The visibility score is the percentage of the night that the target is visible for, and the meridian score is a measure of how close the time that the target passes the meridian is to the middle of the night. Below that there's a graph of the target's altitude versus time centered on 12 a.m. and you have a few indicators here for the rise, the meridian, and the set of the target. And below that is a description that was pulled from Wikipedia. The next tab here is the master catalog. This is a collection of every target that's currently a part of this app. There's about 100 of them right now. And up top you have various different filters that you can apply to this list. In this menu you have access to all those filters again, and you can pick how you want to sort it. So I can sort it by visibility. Here's a quick example of how the filters work. Let's say I wanted to shoot a target on the Messier catalog, and I want that target to be a supernova remnant. Well, looks like the Crab Nebula is the only target that matches those criteria. Let's say instead of a supernova remnant, I want a emission or reflection nebula. Now I have a bunch more options, and then we can further restrict this. Let's say I want to image a target that is bigger than 60 arc minutes. Now my options are further constricted, and I can fine-tune what type of target I'm looking for. Similarly, with the daily report page, I can choose what location I want to do this from and what date I want to do this on. And then I can clear the filters up top just by clicking that X. And then in the settings tab, I have options to add custom locations by putting in the name, latitude, longitude, and then putting the GMT time zone offset here. And you could also just click the current location button to get your current location. You can slide on locations to delete, and similarly in the imaging presets you can add your specific imaging optical setups. So I'll just do a fake one here. Let's say I have a 1500 focal length scope with a 3.76 pixel size, resolution length 6216, width 4152. It tells you the pixel scale and the field of view that this optical setup will have. Then you can go ahead and add that, and now you can use that to help determine your daily report here. And similarly, you can delete these. The report settings gives you a few options to customize what shows up on your daily report. Max allowed moon for broadband is going to determine the cutoff for when broadband imaging is a viable option. And this first setting, prefer broadband targets on moonless nights, you should turn on if you want to prioritize broadband targets over narrowband targets on a moonless night. This third tab, Journal, I have not implemented yet, but what I want it to be is a place to log all the targets that you have imaged for two reasons. One is that then the algorithm here can know if you already imaged one of these targets recently and take that off the list, so that it's not suggesting something that you just took a picture of. And secondly is just because I want a place where I can store information about each of my imaging sessions. So I'm building this part mostly for myself. Now, as you can see, this is an iOS app, and I have no plans to develop an Android version at this time. And right now, this app is not released on the App Store, but I have released it for beta testing. If you follow the link in the description, it will tell you exactly how you can sign up and install this app on your device. It will also allow you to send feedback to me, which I will look at and try to implement as best as I can. Over the past 2 months, I spent over 120 hours working on this app, but it is still far from done. There's lots of bugs and issues that need to be figured out. Hopefully those will get figured out in the beta testing before the actual release. This app is also far from done. There's lots of things I still want to add. For example, the daily report algorithm that chooses which targets you should image is incomplete. It could still use some improvements in how it does that, and I also want to add some more settings here so you can customize it to better serve you. And then in terms of targets, I want to add a lot more targets. There's only 100 right now, and I want to increase that number greatly, as well as adding the ability to add custom targets, and I want to add planetary targets and maybe some other space phenomena. And then in each target itself, I want to improve the UI here and add more detailed target descriptions that I can curate, maybe provide more examples of pictures for different angles, different palettes, or different fields of view of how to image that target. I want to add a widget for this app so that you can, on your home screen, easily access what the best targets are for that night. And another customization I want to add is the ability to add custom horizons to these altitude graphs, which will further increase the accuracy of the visibility score. Hopefully I can release this app within the next month or two on the App Store, and it'll probably be available for a one-time purchase of a few dollars because I would like to recover the cost that it cost me to put the app on the App Store. And if you would like to be notified of when that happens, then please subscribe to my channel and I will upload a video telling you when that is available. But if you want to start using it right now, then I highly recommend you join the beta in the description. So this app is based off of this spreadsheet that I had created about a year ago, and I have featured it before in my video called A Typical Night of Astro Imaging, and on that video I got a few people in the comments who were interested in how this spreadsheet works. So right now I'm going to take a few minutes to briefly go over how I made this spreadsheet. So what it is it's a collection of about, I think it's 110 different deep sky objects here on the left, along with various statistics about each of them. These targets were chosen mainly from the book The 100 Best Astrophotography Targets, as well as from a few astronomy magazine articles. And the information here that's included with each target is here because, well, the RA and DEC are needed for making calculations about the rise and set times, and the other stuff was intended to be used as criteria to determine what target I should use on a given night. I never actually got far enough on this spreadsheet to implement that part of it, so it's kind of just here for show. So my goals with this spreadsheet were to tell me what target I should image on a given night, and to do that I use these two metrics, visibility score and meridian score. The meridian score was a measure of the margin of error between the time the target crossed the meridian and the middle of the night. And the visibility score is the percentage of the night that the target is visible for. And with these two numbers, I was able to sort these targets and figure out which one I should image. Like I said, I had intended to go further with this and select targets based on more criteria, but I never got that far. I only got far enough to create these sorts, which sorts them all in order based on the meridian and visibility scores. So to determine the visibility score, I needed to know when the target rised and set on any given day. And to do that, I used the calculations that I found on this website for converting ARIA and DEC to alt and AS. Now, I wasn't converting ARIA and DEC to alt and AS, I was actually converting alt and AS to ARIA and DEC, where the altitude would be 0, because that's when the target rises and sets. So I had to reverse engineer the equations given on here to go the other way around. And I don't really understand it enough to explain it. I only understood it enough to write it into my spreadsheet. So if you're interested in this, I will link this article in the description. But this is where those calculations are used. And then they're turned into a time and date here. And then with that, I can determine the overlap it has with the nighttime, and then the percentage of the overlap versus the total amount of night. Now, in order for this to work, I also have to have stuff like the moonrise, moonset, sunsets, sunrise, sunset in order for this to work. So this spreadsheet here is just a big table for the entirety of 2022 of all that information, and I had to manually copy and paste this information into here. It was very tedious. This spreadsheet no longer works because it only works for 2022, and I'm not going to update it for 2023 because I don't use this anymore. So that's basically how the spreadsheet works, and this is the basis for how I built the app. So this is the end of the video now, and if you're interested in trying this out, please go to the description and follow the links to join the beta, and stay tuned for the actual release of the app.